Hello everyone. The target of this RecurDyn Beginner Kit is the beginners who are not familiar with RecurDyn. The purpose of this RecurDyn Beginner Kit is to introduce the basic information about how to use RecurDyn. This is the index of this beginner kit. First, let me talk about the basic terminologies of RecurDyn. Then, PreProcessor, body, joint, and other fundamental entities will be introduced. In addition, simulation post-processor will be covered in the later parts. Before we start this, let me ask you one question. Did you already study RecurDyn Starter Kit? It covers the basic information about multibody dynamics and RecurDyn. This beginner kit assumes that you are already familiar with the contents of the starter kit. So, if you haven't studied it yet, I recommend you to study the starter kit first. You can find the starter kit from this link. Part 1. Then, let's start RecurDyn Beginner Kit. First, let me talk about terminology. Bodies are the parts which form a model. Ground is a special body. Its location and the orientation are always fixed. Marker is a component used as a local coordinate system. Joint is a component which constrains the degrees of freedom of bodies. Force is a component which applies force and torque to bodies. If two bodies contact each other, that is where the contact force occurs. Expression is mathematical expression that is used for motion or force. For modeling and simulation, the coordinate system is very important. RecurDyn uses Cartesian coordinate system, x, y, z. It is necessary to understand the difference of absolute coordinate system and local coordinate system. Absolute coordinate system is relative to the inertial reference frame of RecurDyn. The location of the inertial reference frame is at 0, 0, 0, and it is unchangeable. Local coordinate system is relative to a specific reference frame, and the reference frame is usually a marker. This is also called relative coordinates. It is important to know the location and orientation of the reference frame. In this image, this vertex is 0, 0, 0, and this point is expressed relative to this vertex. Let me explain degrees of freedom. The abbreviation is DOF. It is the number of independent motions that are allowed to a body. Any kind of motion can be expressed using one of these motions. What if the motion in the x direction is not allowed? We say that it is constrained and the body has 5 degrees of freedom. Then now, let me introduce the preprocessor of RecurDyn. This was already introduced in the starter kit. System button, ribbon, toolbar, working window, database and navigator, message window, and status bar. You can refer to RecurDyn starter kit for the details. You can find it from here. This is a demo video of RecurDyn preprocessor. This is translate operation. And this is rotate operation. This is rotate with point. You can select the center of the rotation. The shortcut key is Y. This is fit. You can zoom in and out using mouse scroll wheel. This is locked zoom. You can use various shade modes. You can change the render mode of each body separately using each render. To change the working plane, Shift V and Shift B can be very useful. You can use these arrows to rotate the viewpoint. You can turn on and off the icons and markers. And you can change their sizes. This is a demo video about how to change the gravity settings. Open the gravity dialog. You can select the desired direction, then click Update, and then OK. You can see the direction of the gravity arrow has been changed. You can also open the gravity dialog from Analysis dialog. Before we move on to the next, I recommend you to do the workshop number 2. There are several workshops, but in this beginner kit, I recommend you a specific part related to what I've just explained. If you want, it is also a good idea to do all workshops first, then study this beginner kit. You can download the workshop from this link. Now, let me introduce the basic information about body. Bodies are the parts which form a model. There are two types of bodies, which are rigid body and flexible body. Rigid body is a solid body whose deformation is 0 or so small that it can be neglected. It has 6 degrees of freedom. Flexible body is a deformable body based on FEM. It is possible to calculate stress and strain of a flexible body. It has many nodes and each of them has its degree of freedom. This beginner kit covers only rigid body which is solid and not deformable. Even if the flexible body is more realistic, in many cases, deformation is so small that it can be neglected. So, it is efficient to use rigid bodies for simulation instead of flexible body. If you need to consider the flexibility of a body, you can convert any specific rigid body to a flexible body. It is a tremendous advantage of RecurDyn. In Starter Kit, flexible body was explained briefly, and you can find more information about flexible body and multi-flexible body dynamics, aka MFBD, at Function-Based Technical Support site. Even if the flexibility needs to be considered, it is recommended to use rigid bodies for the early steps because it is important to understand the overall behavior of the entire system using rigid bodies first. If flexible bodies are used from the beginning, it is hard to find out the cause when some problems occur. This is the property page of a body. It is also called dialog. Body property page has 4 tabs. In General tab, you can change names, layer, comment of a body. In Graphic property tab, color, transparency, and other graphic properties can be modified. Origin and orientation tab is very important. You can change the origin and orientation of the body here. In Body tab, the material properties such as mass or moment of inertia can be changed. It is possible to create primitive shapes as a body. For example, cylinder, sphere, box, and others. CAD files can be imported as well. It was introduced in the starter kit already. Here, let me explain two more things. First, one is general. In order to modify the shapes of the geometries, you need to enter the body edit mode. Body edit mode will be introduced later. If you click General, empty body is created and body edit mode is automatically activated. The other is ground. Ground, as I explained, a special body whose location and orientation are always fixed, is often used as a road for vehicle simulation. This is a demo video to show body creation. First, create a cylinder. The default option uses 2 points, but there are many other options such as point, point, and radius. You can input radius to input window directly, like this. This shows how to create sphere. There are many options either, and you can also create an ellipsoid by using other option. There are several ways to open the property page. First, use the pop-up menu. Second, select an entity and use shortcut key P. Third, select from database and use the pop-up menu. Fourth, double-click the entity from database. You can open property pages of other entities in the same way. And you can also open property pages from relation map. This is about body property page. Body property page consists of 4 tabs. In General tab, you can change name, unit, command, and layer. In Graphic Property tab, color, render mode, and transparency can be modified. In Origin and Orientation tab, origin and orientation of a body can be changed. This is how to change the orientation using Euler angle. 30 degrees about z-axis, then 90 degrees about x-axis, and then 30 degrees about z-axis again. Material properties are automatically calculated by default, and mass center is calculated automatically also. If you select density type, the body properties are calculated using density. If material input type is set to user input, the position of the center marker can be changed manually. Finally, the values displayed in these property pages are based on the system unit, in this model, mmks. You can change the unit in General tab. If you change kilogram to gram, then the values displayed in this dialog are converted based on it. Let me explain geometry, which is inevitable to describe body. Body consists of geometries, markers, and parametric value and points. Let's assume that there are 3 bodies in a system. Each body can have more than 2 geometries and 2 markers. For example, these 4 geometries are included in one body. For simulation, solver only uses body. Body is a group which consists of several geometries. The mass and moment of inertia of a body are calculated using the geometries in a body. Origin and orientation of a body are defined using global coordinates. Precisely speaking, it doesn't use global coordinates. It uses a local coordinate relative to the reference frame of a subsystem, but let's ignore it here. Geometry has a shape, but it doesn't have material properties. Origin and orientation of a geometry are defined using local coordinates relative to a body reference frame. The reference frame of a body is displayed when the body is selected. I will show you in the next demo video. Each geometry can be edited using various operations such as Boolean, chamfer, or fillet. You should enter body edit mode to create, delete, edit geometries. Let me show you the body edit mode. There are several ways to enter the body edit mode. First, you can select a body and use the pop-up menu. You can exit using by clicking Exit button. You can double-click a body to enter its body edit mode. You can create several geometries in one body. The reference frame of a geometry is displayed when selected. You can use various local operations such as unite, subtract, or fillet in this edit mode. This is subtract. This is fillet. You can change the length or radius of the geometries also here. I already explained the body consists of geometries and markers. Since markers are included in a body, if a body moves, markers move together. Marker is often used as a reference frame. There are 3 kinds of markers. First, center marker, CM, is a marker created at the mass center. One body can have only one center marker. Second, general marker. It can be created by user, or they are generated when joint or force is created. Third, floating marker is a special marker, which is created when entities such as PTCV or CVCV are created. It doesn't have fixed location, so it is called floating marker, which means it acts as if it is floating. Let me introduce the property pages of a marker. General tab and origin and orientation tab look the same as body property pages. Please note that this origin and orientation are relative to the body reference frame. In Marker tab, you can change the model body, which includes the marker. RecurDyn provides several options to create a marker. For example, body point is used to create a marker at the middle of 2 points. This is workshop 4. You can use the functions related to body and geometry.